Hi everybody, welcome to section 7.3. We're going to take 7.3 in two parts. We're going to talk about rational exponents first. Section 7.3b will solve some equations with these rational exponents. So first of all, a rational exponent is an exponent that is a fraction. For example, we might have x to the 2/3 power. So we've got a base of x and the 2/3 is the actual exponent. Or maybe we'll have a 100 to the 1/2 power. So 100 is the base, and the 1/2 fraction is the exponent. So let's talk about what these mean and how we can simplify those and write them in a different way. So we're going to start with the nth root. There's some crazy things happening. We're going to start with this second box right here. Let's write down what it means, and then we can put an example up there so you can see it. So it says that for the nth root, if a to the n power equals b, then the nth root of b equals a. Doesn't make a whole lot of sense when you look at it like that, but let's put some numbers in there. So if I say if 2 to the 3rd power equals 8, you can check my math on that, right? 2 times 2 times 2, I'm going to multiply those all together. It's not 6. Then I can say that the 3rd root of 8 equals 2. Notice I've got all the same numbers there. That base of 2 became my answer. That 8 that was my answer became underneath that radical box. And the 3 that was the exponent became the cubed root that we're taking. So we can go back and forth between square root or between roots and exponents. That's kind of the definition of the whole thing. So let's talk about when we've got a b to the 1/2 power. So here's what this says. Anytime you have a number to the 1/2 power, that equals the square root of that number. So for example, if I have well, let's use our 100. 100 to the 1/2 power, that's the same as saying the square root of 100. And everybody knows the square root of 100. Remember, we're thinking about repeat multiplication. What times itself, because it's a square root, so there's 2 of them. What times itself will give you 100, and we know the answer is 10. So I could say that 100 to the 1/2 power equals 10. Or I could say something like, why don't I move this? I could say something like the square root of 15 is the same as saying 15 to the 1/2 power. If I wanted to say it that way, I could. So you can switch back and forth between square roots and 1/2 powers. So along the same lines, I don't know why I typed these in a different order, if we look at this b to the 1/n power, it's going to be kind of the same thing. What this says is that b to the 1/n, so it's a fraction, 1/2, 1/3, 1/4, 1/10, is equal to the nth root of b. So I could say something like 8 to the 1/3 power is the same as asking for the cubed root of 8. So in other words, I'm thinking what times itself 3 times will give me an 8. If I use my calculator or my common sense, I'll know that that's a 2. So the cubed root of 8 equals 2, or 8 to the 1/3 power equals 2. Or I could say something like, see if I can trick you, 32 to the 1/5 power. How would you write that with a radical? The square root or cubed root box is called the radical. I could say that is the 5th root of 32. That 5 is actually sitting inside the little check mark, inside the little crook of the box. So now I'm thinking of what times itself 5 times will give me a 32. I happen to know that answer is also 2. So if I go to my calculator and type in 2 times 2 times 2 times 2 times 2, it will give me a 32. This last one is the one that messes people up the most. It says that b to the m over n power, notice that's a fraction, so it could be 3/2, it could be 7/5, it could be anything. That is equal to two options. You've got one option. Notice our b stayed the same. Our b is our base. And then we can take, and I always picture it like this. The denominator flies around and goes into that little crook of the radical box. The numerator of that fraction, the m in this case, stays as the exponent on that b. The second option is just the same thing. Notice everything's in the same place. The n is still in the crook or the check of that radical box. The b is still sitting in there, but this time I just took the m and I moved it outside. What that tells you is that you can take the nth root of something and then move it to a power, or you can do that b to a power and then take the nth root of it. A bit mind-boggling to start off with, right? So let's do an 8 this time to the 2/3 power. Now when you do 8 to the 2/3 power, and I know that your calculator might do this for you, but I'm going to ask you to write it out using a radical, so a square root box. So we're going to make our square root box. We know that our 8 is going to stay as our number. I'm going to take that denominator 3 and fly it around. So that's the one that ends up out on that outside of the radical box. The 2 will stay as an exponent on the 8. So you got a couple options. So the two options, this big or here in the middle of that, says that you could either take 8 to the 2nd power and then take the cubed root of it, or you could take the cubed root of 8 and then raise that to the 2nd power. It doesn't matter which way you do it because it's all the same thing. So if you wanted to do this last choice right here, the cubed root of 8, we know from the example up above is 2. And then when we square it, we get a 4. If I do it the other way, I take 8 squared. I would be taking the cubed root of 64. I go to my calculator or think to myself, what times itself will give me a 64. I know that that answer will also be 4. It's really more about switching that exponent and putting the denominator as the part outside the radical box, the numerator as the part inside. It's more about that than the actual finding of the answer 4. I want to see that you know where the 8 goes and where the 2/3 goes. All right, so that's all our big stuff. So let's write some of these problems. It says to write each expression in radical form or write each radical in exponential form. So in other words, we're not evaluating anything even if we can. So for number 1, if I've got a 36 to the 1/2, I feel like everybody can figure that out, right? Go back to that box, that very top one. Anything to the 1/2 means we're just taking the square root of that anything. No problem. It doesn't say to evaluate it. I know you could tell me that it's 6, but it's fine. Number 2 is a trick problem. Is the 1/2 exponent on the x or the 5 and the x? Compare it to problem number 3 when you answer that question. The 1/2 is only on the x, right? The 5 isn't doing anything but sitting out in the front. So I would keep the 5 as just sitting outside. And then I would take this 1x to the 1/2 power and do the same thing that we did with that last problem with the 36. I'm going to take the square root of x. But number 13, that 1/2 power, because I've got exponents, the 1/2 is on the 19, the a, and the b, all in big set of parentheses. So I'm going to take a giant square root, and oops, what did I do? I'm going to take my giant square root, and I am going to put the whole 19a and b inside there. There it is. So that's switching from that 1/2 to the radical form. Radical form is when you've got a radical. Exponential form is when you got an exponent. So number 4, square root of 12. Well, if we just look above it, we're going to do exactly the opposite. It's got a radical, so I want it to have an exponent. So I would just do 12 to the 1/2 power. I know you could go to your calculator and get 3 point something, but I do not want irrational numbers. I want exponents or radicals. 5 is going to be just like number 3 because the whole 18b is inside that square root sign. When it's just a square root, that's when I know I've got myself a 1/2. Kind of getting the hang of working back and forth. Number 6, we threw in one extra piece of information, and that would be that 3 exponent right there, right? So my whole 37h is inside that radical. And now what am I going to put for my exponent that is a fraction? Am I going to have a 1/2 this time? Because that is a 3, I'm going to have a 1/3 this time. Secretly, that is a 2 in the square root box. That's why it's the square root of 12 or the square root of 18b. Square means a 2. So that's just going back and forth between those two types of problems, radicals and exponential. So this one says to convert, then evaluate. So you might do them in different order. I know that your calculator will do a cubed root of 125. If I had asked you as a exponential, it would have been 25 to the 1/3. So that's the other form. I know your calculator will do the work, but going back to the original problem, this tells me what times itself, something times something times something will equal 125. That would be a 5. It's repeat multiplication. How about a number 9? How about 27 to the 1/3 power? So if I'm going to rewrite that, it says to convert it, so I'm going to write it the other way. That means I'm going to do a cubed root of that base 27. And really what I'm asking is something times something times something equals 27. What do those 3 equal values have to be? 3 times 3. Oh, my goodness. 3 times 3 times 3, right, will get us a 27. My board is a little crabby today. Sorry. Just fill in those 3's. So that means that 3 to the 3rd power, or the cubed root of 27, is 3. All right. All right, so these problems are really the same thing. We're going to go back and forth, and then we're going to actually evaluate. Remember, whenever it says evaluate, that's when you want to find a number answer. If I'm asking you to evaluate, they're going to come out to nice, neat numbers, not irrationals. I won't ask for a number if it's an irrational. So here's what I would like to know. What's the trickiest part about fraction exponents? What do you see when you've got a fraction exponent, a 1/3, a 1/2, a 2/3? What's the trickiest thing about them? Maybe turning them into radical form, or figuring out where the variable or the denominator goes, or something. This one, I just want you to write this as a rational expression. I want you to have an exponent, so a base to a power. What will that base be? And what will that power be? You do not have to evaluate it. I just ask you to write it out in the other form. That is it for lesson 7-3A. Thanks so much. Bring your questions to class. This one we're going to need some practice on, I know. So make sure you bring questions so we can work on these. Have a good one. See you next time.